different orbitals actually correspond to areas on our periodic table. So our S block is made up of the alkaline metals and alkaline earth metals. All right. Then I'm going to move my little picture. Then we have our P block, and our P block is made up of groups 13 to 18. Our D block is the transition metals. And then last but certainly not least, our F block is the lanthanides and actinide series. And so we're going to go ahead and color that down here. All right, so my S block is right here. Now guys, in my S block, helium does like move over. So helium is part of the S block, even though technically it's not an alkali or alkaline earth metal. Helium is kind of our one exception to that. And then my P block is over here. I know my drawings are not perfect. And my D block is in the center. And last but not least, my F block is the lanthanides and the actinides down there at the bottom. Okay, so those are my orbitals. Let's label them now. So we have S. I think I'm just going to actually label outside instead of labeling. Oh no. Sad. Okay. Label outside instead of labeling on. So this is our S. It's our D. It's our P. That's our F orbital. What is wrong with me? Just wrote a 4. F orbital. There we go. All right. Now each orbital does hold a specific number of electrons. So our S orbital only holds 2 electrons. Our P orbital holds 6 electrons. 10 electrons. And our F orbital holds 14. All right. So this is what we've got so far. We are going to come back to this, so don't get too comfy when we move away. All right. So energy levels. There are 7 energy levels where electrons are located. And in general, they follow the row of the periodic table, except for the D and F block. So in general, they follow the row on the periodic table, except for the D and F block. All right, guys, so like this, be row 1, 2, 3, 4, 5, 6, and 7. So for D, the D orbital, it's always 1 less than the row it's on. So if it's on the 4th row, it would be 3D. If it's on the 5th row, it would be 4D. 6th row, 5D, and then 7th row would be 6D. And then for our F orbital, guys, remember our F orbital is inserted like right here in our periodic table in between our S and our D block right there. So it's always 2 rows below. So if that was the 6th row, then this would be 4F. And then the 7th row, this is 5F. So those are kind of our exceptions to the row rule. All right. So now let's look at what our electron configuration actually looks like. And our electron configuration is essentially just a visual representation of the arrangement of electrons in an atom. And I always like to think of it as we are taking a census of where all of the electrons that are available for bonding are located. So, and it's going to be, your electron configuration is going to be a sequence of numbers and letters. So 1s2 is the electron configuration for helium. So our 1 corresponds to our energy level, which is kind of like your street that you live on at your house. It tells you in general where these electrons are located. And then our S is our orbital. So what orbital are we in? Not orbital. This is our sublevel. So our S is our sublevel, and that tells us specifically like where are electrons located. So S would be like your house number. Like, okay, you live on 516 imaginary street lane. I don't know. And so 516 is the house number then. And then finally, right there, the last number, the 2, would represent the number of electrons. And so that is like the number of people in the house. So if I live at 516 imaginary street lane, and there's 2 people in the house, then that is what that is telling me. All right. So that's the basics of electron configuration. So now we are actually going to write some electron configurations. We are going to start by writing the electron configuration for phosphorus. Okay. And I'm going to use my large periodic table to show you guys what I'm doing. So follow along as we are talking through that. Hi guys! So this is our first practice problem, and we are trying to write the configuration for phosphorus. I've marked it there with that lovely orange Post-it note so you can find it. It's number 15. All right, so we're going to start by writing our configuration. Remember, when you write your configuration, you move from left to right, top to bottom. Always start at the beginning, just like we're reading a book. All right, our configuration has 3 components to it: the energy level, the sublevel, and the number of electrons. So let's get started. So very first, we're going to start at the very beginning of our periodic table, as always. And when we start at the very beginning, the first thing we need to figure out is our energy level. Hydrogen is on the first period, or the first row, so that means it is in the first energy level. These first 2 groups right here, the alkali metals and alkaline earth metals, are both in the S sublevel. And we need to cross 2 boxes, so that tells us how many electrons we need. So 1 for hydrogen, 2 for helium. So then the first part of our electron configuration is 1s2. Okay? Now then we've moved all the way left to right, so now we need to go to the next row. When we go to the next row, our next part is that we are on the second row. So 2, first 2 groups right here, so that's the s orbital. And we are crossing 1, 2 boxes. So 2s2. We're going to continue on the second row over here. So now we're still on the second row, so still second energy level, 2. We are in a different sublevel though. So right here, groups 13 to 18 are part of our P sublevel. So 2p, then we have to figure out how many boxes we cross. Each box represents an electron. 1, 2, 3, 4, 5, 6. So 2p6. I know, I probably wasn't actually following the boxes there. I did my best. Okay, now we're at the end of the row. Come on down right here. So now we are on the third energy level, S sublevel. We are crossing 1, 2 boxes. Keep moving on. Still on the third energy level. Now we are in the p orbital. And to get to phosphorus, we need to cross 1, 2, 3 boxes. So our final configuration, I'm going to take it up to the camera so they can see, for phosphorus would be 1s2, 2s2, 2p6, 3s2, 3p3. We are doing the electron configuration for sodium, Na, number 11 on your periodic table. All right, so still going to start at the very beginning. Always start with hydrogen. Move left to right. So first energy level. So 1 S sublevel of these 2 groups right here. And then how many boxes do we cross? 1, 2. So 1s2, first part of our configuration. Moved all the way across the first row, so now we move to the second row. 2 S sublevel right here. And then we cross 1, 2 boxes. All right, keep moving across our second energy level, and we are in a different sublevel now. Still on the second energy level. We are in the P sublevel now, and we go across 1, 2, 3, 4, 5, 6. So 2p6. And then right here, third energy level, S sublevel, cross one box. So 3s1. And that's it. That's our configuration. So final configuration is 1s2, 2s2, 2p6, 3s1. Hi! Oh, we don't need to do that.
Okay, it's fine for a second.
This time we are doing yttrium, which is one of my favorite elements. All right, so we're going to start at the beginning just like last time. What I do want to point out, guys, is so far we've only worked with the S and P sublevels, and this time we're bringing in the D sublevel, so that's going to add a little twist to it. All right, so let's get started. So, still start at the beginning. 1 S sublevel, crossing 1, 2 boxes. All right, now we've finished the first row. So now 2 S sublevel, we cross 1, 2 boxes. Keep moving across that sublevel. 2 P sublevel, and we cross 1, 2, 3, 4, 5, 6 boxes here. 3 S sublevel, we cross 1, 2 boxes, so 3s2. Keep moving. Third energy level, P sublevel now, and we cross 1, 2, 3, 4, 5, 6 boxes. 3p6. All right, he's gonna continue on the next row. Now, fourth energy level, S sublevel, and we cross 1, 2 boxes. Okay, so now we're in the d orbital. Guys, remember I told you the d orbital is always 1 energy level lower than the row it's on. So we're on the 4th row here, so that means our d orbital is going to be 3. So we have 3d, or d sublevel, and we're going to cross 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. Woo, 3d10. Okay, now we're in the p orbital. Guys, remember your p orbital is normal, so we are on the 4th row, so it's going to be 4p, and we're going to cross 1, 2, 3, 4, 5, 6 boxes. Almost there. 5th row, s orbital, crossing 1, 2 boxes. And then last but certainly not least, we're in our d orbital. D orbital is always 1 below, so 4d. And we just cross 1 box, so 4d1. So that leaves us with our final electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d1. Get ready. We're going to go a little faster this time. This time we are doing gold. It is all the way on the 6th row. So you'll notice that this time we are not only just going through the S, P, and D, but we are also going to add in the F orbital. So real quick, I want to show you guys what this looks like. So if I look at my periodic table, my F orbital is actually inserted in rows 6 and 7, it's inserted in between my S and my transition metals. So this is what the periodic table should look like. The only reason our periodic table doesn't look this way is because obviously it doesn't fit on a piece of paper. So we can't print it this way, but this is what it should look like. All right? So let's get started with our configuration. So starting all the way up at the beginning with hydrogen, we are in the 1st energy level, S sublevel. And we cross 1, 2 boxes, so 1s2. Moving right along, 2nd energy level, S sublevel, and cross 2 boxes. Keep moving left to right along that row. We are on the 2nd energy level still. P sublevel, we're going to cross 6 boxes there, so 2p6. 3rd energy level, S sublevel, cross 2 boxes, so 3s2. Keep moving, 3rd energy level, P sublevel, and we cross 6 boxes, so it'd be 3p6. Fourth energy level, S sublevel, cross 2 boxes, so 4s2. Now guys, we're in our D sublevel, so remember it's always 1 energy level lower. So you're on the 4th row, so this is going to be 3D. 3D, and we cross 10 boxes. All right, now then we're back in the P sublevel, so we go back up to our normal row, so that's 4P, and we're gonna cross 6 boxes there. All right, 5th row, 5th energy level, S sublevel, cross 2 boxes. All right, now then we're on the D sublevel, so once again down 1 row, so we have 4D, and we're going to cross 10 boxes. Now then we're in our P sublevel, so go back up to the normal row, so we have 5P, and we're going to cross 6 boxes here. All right, and then we have 6 S sublevel, we cross 2 boxes. Now here, guys, here is where we come down. This is where our F sublevel is introduced. So I'm going to come hold up this periodic table for you guys. So right after our 6s2, we go into our F sublevel. On our periodic tables, some of the elements are pulled out, so there should be an element right here. All right, and that is, kind of depends. We'll talk about those exceptions later. But for now, we're going to say that LU that's over here is actually part of the D sublevel. So we have F sublevel is down 2 rows, so we're on the 6th row, so this is 4F, and then we're going to cross 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, with this YB being there. You guys remember LU is actually part of our D sublevel, and that's how it's written on the periodic table that's on Canvas for y'all. All right, so F. Now then we're in our D sublevel. So remember your D sublevel is down 1 row, so we're on the 6th row. So we have 5D, and then we're gonna count how many boxes. So this is an imaginary one. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5D9. So our final electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d9. Let's go over the 4 practice problems. So these were pretty long, so let's see how you did. So we'll start with the hardest one right here of neptunium. All right, so neptunium we have is all the way down here in my F sublevel. So for neptunium we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then remember, the D is down 1, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, and then we go down to our F, 4F14, 5D10, 6D10, 6P6, 7S2, and then we come down to our F sublevel and we have 5F5 because we crossed 5 boxes in our F sublevel. All right, so that's neptunium. Next, we had carbon. Carbon was much easier. So it was 1s2, 2s2, 2p2. And tellurium. Again, a long one. So 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and then 5p4. And then we also had europium, which was also pretty long. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f7, because we crossed 7 boxes in the f orbital.